Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about Leetcode question number 767, Reorganize String. Given a string S, rearrange the character of S so that any two adjacent characters are not same. If there is no possible rearrangement, then just return empty string. Okay, for example, AAB, then I can rearrange it as ABA. Okay, meanwhile, AAAB cannot be rearranged such that there won't be a condition like two adjacent characters won't be different. In that scenario, I'll be returning what? An empty string. Okay, so see here, the approach here is very simple. Don't overcomplicate it. Okay, so if this is a given string, whether I'll be taking this A or taking this B at first, I'll be taking the A first. Why? Because A's count is larger. If I take B, then I am forced to take two A's at next. So this is the reason why I am taking the maximum count first. So I will be taking the A at first, then B, then A. Can you understand this? By doing this, I can complete the condition they have given in the question. Okay. Similarly, come to this big example. Here they have what are all the elements there. So what are the unique elements there? So A is equal to 2, B is equal to 3, and C is equal to 4. So these are all the count of those unique elements. Now listen this carefully. By using this example, what should be rearranged first? So C should be rearranged first. Okay, put C here and make this as 3. Okay, fine. Now what is the maximum character here? What is the maximum count? I have B and also C. Okay, whether I want to take the C or B, I'll be taking the C. Sorry, I will be taking the B, right? Because C is already occurred here. If I take again a C, it leads to what? Two adjacent same characters. So for this reason, I'll be taking B. Okay, if I take B, it will be something like CB, and this will be leading to 2. Can you understand up to this? Yes. Now after this, what is the maximum character I have? C. C is the maximum count I have. Whether the last inserted element is a C, no. So just insert C here and make this as 2. Okay. Now whether I can insert C, because all three are same count. Now whether I can insert C here, no, not at all. Whether I can insert B here, yes, you may. So what is my next thing going to be? It is B, and make this as 1. Okay. Now again, whether C or A, which should be coming next to this B, because these both are of higher count in this series, and also previous number is not equal to these two numbers. So what I am going to suppose to take, I can either take the C or A. That's your wish. Okay, I'll be taking this C. Okay, so if I take the C, it will be C here and it will becomes 1. Now there is only choice. I only take this A. Okay, let us check what is the last element. It is C only, so I can take the A. So take A and make this as 1. Okay, now I have three choices to take. Whether I can take this A, no, because previously inserted element is A, so I can only take C or B. So for me, I will be taking this C. Okay, I'll be taking this C. Fine. Now the C count will becomes 0. Now what are all the other choices I have? I have A and B, because lastly I inserted C, so I can insert only A and B. So I prefer to insert A. Insert B. Okay. Now this will be changed to 0. Now A. So A is only the leftover thing, right? Because it has 1. And also the previous value is B. If the previous value is A, then we will be returning what? False, which means the empty string. Since the last value is B, the previously inserted value is B, A can be just inserted here and it will be made to 0. Now all the characters are taken into consideration. So this is going to be the result. That's it. This is one of the result. Okay, that may be any order. Okay, that may be another answer also, but this is one of the answer. Can you understand this? Fine. Now how we are going to make this into a coding logic? Now I have given you the basic logic. Also by using this basic logic, try by yourself. Now let us go to the coding logic, how we are going to do this. So let me take the string BB AA CC B CC. Okay, Now initially I'll be taking a hash map to count each and every characters in the string. So I'll be taking a hash map. Now I'll be standing here. So B will be initially 1. Okay. Now next B. So B will be again incremented by 1 and it will be 2. Now A will be 1. Again it is A. So A is incremented by 1 and it is 2. Now C is 1 now. Again C. So C is incremented by 2. B. So B is incremented by 1 which is equal to 2. Okay. Now again C. So C becomes 3. Again C. So C becomes 4. Now my hash map contains the values of what? A2, B3, C4, right? So these are the values in the hash map. Now I want a data structure. Observe this carefully. This is going to be more important. So I want a data structure such that the data structure will always give me the top element as maximum. So what is the data structure I'm going to use? I'm going to use heap or priority queue. Hope you understand this. Okay. So heap or priority queue will always give me the top element as maximum if we are using a maximum heap. Okay, max heap. If we are using a min heap, then it will be giving the top element as the minimum value. But as of now, we need only the maximum value. For such reason, I am using the max heap. Okay, let's get started. So let me take this. So this, okay. So this is the dictionary we got, right? So I'll be inserting these dictionary key value into the heap in a reverse fashion. Like, so let me design a heap. So this is the heap. Just imagine. Okay, let me put like this. So this is the heap. Just imagine like this. Okay. Now inside this heap, I am going to just push each and everything. In what order? This count will be the first element. Meanwhile, these letters will be the second element. Okay. In such a way, like count will be first element. So 4, C. So this is going to be the heap's first value, and 3, B. Okay. Now 2, A. So this is how I will be inserting into the heap. Okay. So don't worry about what are the things in the heap. Just understand when we are popping out some values from the heap will be popping out the maximum count from the heap data structure. Okay. That's the thing you want to know. Okay, fine. So let's get started now. So initially, what is the when we are popping this heap? So see here is the resultant. Now I'm going to pop an element from this heap. So what is the maximum element in the heap? It is 4, right? It is 4. So I'll be popping this value from the heap. Okay. Now here comes what? Here comes C first because there is nothing present in the result, right? So I'll be inserting C at first. Okay, in my string. Now I'll be adding here like 3, C because C is added one time. So decrement its count by 1 and add it again into the heap data structure. Okay. Now again, if I do a heap pop, again, this value will be heaped out. Why? Because 3 is the maximum value, and also you can argue that 3 is also here, but C is greater than B, right? So for that reason, it will be popped out first in the max heap. Always remember this. Now I'll be checking whether my previous value I inserted is also C. Yes, it also C. So I'll be checking whether my priority queue is empty. No, it has some values. So take those values. So I'll be again pop out the maximum value. Now what is the maximum value? This is the maximum value, right? Now B. So B is not the previous. So I'll be just putting a B here. Okay. Now how I am going to insert into the heap? I'm going to heap push like 2, B and then 3, C because I didn't took C, but I took B one time. So that's the reason why B is decremented by 1. Now hope you understand this clearly, right? Now again, what is the maximum value in the heap that going to be popped out? So it is this value. So it is popped out, and here comes what? C, and because this B is not equal to C. The previously inserted element is not equal to C. That's the reason why C is inserted into the resultant. Now again into the heap. Here comes what? 2 comma C. 2 comma C. Okay, fine. Now what is the next step? So next step is I am going to heap pop the maximum value. When I am popping out from the heap, this is going to the maximum value as of now, because everything is 2 and here the next value is C. C is greater than B and A, right? So it will be popped out. It will be popped out. So here comes C, but its previous value is C. In this case, what I am going to do, I will be not inserting the C. Again, I will be heap popping. Again, I will be heap popping. So this will be heaped out, popped out. Okay. So now B is added here. B is added here. Observe this clearly. And then inside my heap. So let me draw the heap down. So this is the heap continuation. Okay. I didn't have space for that. Okay. Now C will be inserted like 2 comma C. Okay. But B will be inserted like 1 comma B. Can I understand this? 1 comma B. Okay. Fine. Fine. So now next, when I am heap popping, when I am heap popping, the C is the greatest value, because here it is 2 and here also 2, but A is lesser than C. So I'll be popping this C out. C out. Okay. Now whether I can insert C here? Yes, you may. So insert the C, and here comes what? 1 comma C. 1 comma C. Decrement the C count by 1. Okay. Okay. Now again, what is the maximum value in the heap? It is 2 comma A. 2 comma A. So pop it out. Okay. Now here comes what? Here comes A, because the previously inserted element is C. So that's the reason why I'm inserting A, and then here comes 1 comma A. That's it. Okay. Now again, what is the maximum element among this? So this is the maximum element. So insert C, and now what is the count of C? Count of C is 0 comma C. Whether I can insert like this? No. Whenever some count becomes 0, just leave it. Okay. Don't insert again into the heap. Okay. Fine. Now what is the maximum value among these? So 1 comma B. Okay. So now insert B here, and whether I want to insert 0 comma B? No, just leave as it is. Okay. Now 1 comma A. Now that's it. My heap is empty. So hereby I'll be just returning the result as CBC, BC, AC, BA. So see here, no two adjacent characters are same, right? So this is what the entire logic going to be. So now let us have with triple A and B, which is going to be the false case, right? So triple A and B. Now if I just take the count, then the hash map will be A3 and B1. Now if I use the heap, if I push these elements into the heap, then the heap element contains B comma 1 comma B, and then 3 comma A. So this is what it contains. Okay. Now what is the maximum element among these? So when I'm heap popping it, so this element will be popped out. So what is my result? My result will be A first, and then here I will insert 2 comma A. Okay. Now again what is the maximum element among these? So 2 is the maximum element. So I will be popping this, but A cannot be inserted here because its previous element is also A, right? So I will be heap popping again. So here comes what? B. So B is inserted here. Now whether I want to insert 0 comma B? No. Whenever the value is 0, just ignore it. Now here comes 1 comma A. Okay. Now sorry, 2 comma A, because A is not inserted, right? So 2 comma A. Now what is the maximum value among this? So 2 comma A is the maximum value. So pop it out, and A is inserted here, and again 1 comma A is inserted into the heap data structure. Now what is the maximum value among this? So 1 comma A. So just pop it out. Now whether I can insert A here? No, because its previous value is A. So I'll be going and checking whether the heap is empty or not. Yes, the heap is empty. Which means I have no choice, and I'll be returning what? I'll be returning empty string. That's it. Can I understand this? Okay. Now tell me, what is the time complexity and the space complexity of this particular code? So the time complexity will be over. See here, first of all, we are using a dictionary. For the dictionary, we will be having a n log n, and this will be approximately equal to n, because we only have 26 alphabets. That's the reason why we are only having a time complexity of n, plus we are using a heap. we are using a heap and we are heap pushing these elements and popping it out. So this will be leading to n log n. Okay, and space complexity will be O of n because of the auxiliary space like hash map and also heap. Meanwhile, hash map will be of constant space, but the heap will be taking O of n. So this is what the time and space complexity analysis for the particular problem. So see here, it is going to be the code implementation. So I have implemented using this Python. If you want C++ or Java code, just go and search in the description. Okay. So see here, first of all, I'm taking a dictionary, the hash map, and then I'm just traversing upon the string, the given string, and I'm just checking whether that particular character is not in the dictionary. If it is not, then I'll be initializing as 1. If it is already there, then I'll be incrementing it by 1. So this entire thing will be like counting it. You can also use the counter function also, okay, in the inbuilt function, but I prefer not to use the inbuilt function. Okay, fine. Now frequency and the result. So frequency will be equal to the empty list, okay, and result will be going to be the empty string. Now I'll be taking all the key value pairs from the dictionary and I'll be inserting it in a reverse fashion. Like first I'll be inserting the value, next I'll be inserting the key, as I mentioned in the drawing explanation. So see here what I'm doing here, minus d of I. See here, when you are using a C++, you have the max heap, but when you are using a Python or Java, you only have a min heap. So to convert a min heap into a max heap, we'll be using a minus sign. Okay, this and all you should know by yourself. Okay, at first. Okay, fine. Now, and then I'll be just heapifying the frequency array. Now I got the max heap. Okay, fine. Now I'll be just iterating over the frequency until the heap becomes empty. Okay. Now what I'm taking, first of all, value comma character is equal to heap pop of the frequency heap. Okay. Now if the result is empty, or else the length of the resultant is greater than or equal to 1, and also result last element is not equal to the character, then what should I do? I'll be just making my result to append the character. This character we have taken currently. That's what I have explained in the drawing explanation also, right? Now I'll be making my value plus is equal to 1. Okay, because you may ask, hey, there in drawing explanation we have taken minus 1. We are decrementing the count by minus 1, right? But here, see here it is minus value. That's the reason why I am doing a plus operation here for the value. Can you understand this? Yes. Okay. Now else what should I do? I will be checking whether my heap is empty. If it is so, I will be returning just an empty string, as I given a second example, right? There this case occurred. Else what should I do? I will be taking val1 comma character 1 as heap pop off, which means I already popped some value from the heap, but it is inserted recently. It is going to the previous value. So again I will be heap popping the next value, right? So that's the value this. Okay. Now result plus is equal to character 1. Then value 1 plus equal to 1. So here I have appended in the result, or I have concatenated in the result as character 1, and this value 1 is incremented by 1, which means the count is decremented by 1. Can you understand this? Since it is in a negative format, I want to do plus 1. If you are using C++, then here you don't do anything like this, so negative. So at that case you will be doing here like minus is equal to 1. Okay, in description just go and watch that C++ also, the solution also. Okay, fine. Now after, if value 1 is not equal to 0, then only I want to again heap push that particular value 1 and character 1, because whenever the value becomes 0, the count becomes 0, then I should stop there itself, right? So for that reason only I am checking here. After that, here also I should check whether the value, which means that first popped element. So here I have done, right? So here also I have checked whether the value is not equal to 0. If it is so only, then I want to push it into the heap again. Okay, else I don't want to do anything. Now at last I'll be returning the result. That's it. So this is going to be the Python code. Let me submit it. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel. And if you have any doubts, just comment below. And I know this problem is quite difficult to understand, but still I want you to just dry run this code and understand the logic behind it, because we are using the heap data structure. You want to know about why we are using the heap data structure, and also why we are just using this logic behind it, because this logic will be helpful to solve plenty of heap questions. Okay, thank you.